today. If we take a look, we need to know how to graph these. Okay, and we're doing it based on the parent function for log. So if I give you this function, f of x equals negative log base 3 of x plus 4, what is my parent function? What is my parent function? Log base what? 3. Log base 3. So I'm going to come down here and say log base 3 of x equals f of x. This is all side work, ladies and gentlemen. This is all side work. This is to help you graph it. I'm going to convert this to exponential. To convert, remember, 3 to the power of f of x equals x. And I'm just going to make my parent table. How many points am I telling you that you are required to graph?
3.
3. So I'm going to come here and say, here's my parent table. Am I going to take numbers for x or y? Am I going to plug numbers in for x or y? Y, because y is our exponent. So give me a number you'd like to have as your exponent. 1. All right, what is 3 to the first?
3.
Give me another one.
2.
Heard 0. What is anything to the power of 0?
1.
And one more?
2.
What is 3 squared?
9.
All right, so I have my parent table here. Does it take long to make?
No.
No. So if we take a look, let's go back to our function we are given. Who can tell me a transformation we have?
Left 4.
Left 4. When I shift left 4, what does that affect? Your x's or your y's? X's. So I'm going to come to all my x values and subtract 4. I'm just going to write this in for right now. I'm not going to do any math. Do I have any other transformations?
Reflect over x-axis.
Reflect over the x-axis. When I reflect over the x-axis, what changes? So think about it. If I have something up here and I reflect over, what changes? The y values. What do I have to do to my y values? Change the sign. So I'm going to come here and just draw in a negative. Changing all those signs. Questions on any of that? No? All right, let's fill in my table for this function. What is 1 minus 4? So I'm going back to my parent function and doing the math here. 1 minus 4.
-3.
And then opposite of 0 is just 0. What is 3 minus 4? Negative 1. And then opposite of positive 1 is negative 1 for the y. What is 9 minus 4? 5. Opposite of positive 2 is negative 2. So that's my y. Questions? All right. Knowing that we went left 4, does that affect my asymptote?
Yes.
Yes. Where's my asymptote now? X equals negative 4. So I'm going to draw that in. Ladies and gentlemen, make sure you draw that in. And I'm also going to fill that in for the equation of my asymptote. X equals negative 4. Once you have that, go ahead and plot your 3 points and sketch your graph. What is my domain of this exponential function? What are your x values? Where do we start? Negative 4 to infinity. Good. Do I include negative 4? No. And range for exponential, or not, for log? Negative infinity to infinity, all real numbers. X-intercept, where's the x-intercept at? If you can't see it on the graph here, you can always come to your table, see where y is equal to 0, and just copy that point down, -3, 0. All right, let's talk about end behavior and asymptotic behavior. If we take a look here, let's look at the left-hand side. Are we going to have end behavior on this left side of the graph or asymptotic behavior? Asymptotic behavior, good. Remember, asymptotic means it's going towards the asymptote. The limit as x is approaching what? -4, and from which side? The positive side, the right side of the graph. So I need that little plus sign. All right, I'm going to leave what the function's doing blank for right now. Let's take a look at the right-hand side. X is approaching. And is this end behavior or asymptotic behavior? End behavior. Good. All right, we filled in our domain, right? We have -4 and infinity, just like our domain says. Yes, Lily?
How do we know again about the plus?
The plus side?
Yeah.
So if it's on the right-hand side, the right-hand side of the graph is usually mostly positive, right?
Yeah.
That's how you know. Okay, if you're more on the positive side with positive x values, it's plus. If you're over here where the x values are negative mostly,
But isn't the -4 on the negative side?
but our function is where? Where's your function? It's on, we only use negative numbers up to here.
Going like that.
I'm sorry, what?
So you're going like up.
You're just looking at what side is your function on. So if we talk about this side here, this would be positive, this side would be negative, right? We're mostly on the positive side. We only cross over to negative numbers for a little bit. You can also look at your domain. You're going from negative infinity or -4 until what type of infinity? Positive. That can also help you. If you notice you have positive infinity in your domain, that'll tell you to put a plus sign on it. Okay? All right. If we take a look here, as we're approaching the asymptote, what is our function doing? Where is it going? To positive infinity. Okay? Once you know you use positive infinity, what should you automatically be thinking about your range? The other side has to be negative infinity. You can't use both. You can't use only one. You have to have both. So once you use one, you know the other one has to be the opposite, which if we also look at the graph, is our function going down?
Yes.
Yes. So use process of elimination, guys. Yes.
What happened to x plus 4 when you transferred into the original?
We subtracted 4 from the x's. So if we look at my table here, I put -4 because we're shifting left.
Okay.
Make sense? All right. If we take a look at the next one, what is my parent function? I'm going to help you guys set this up real quick, and then I want you guys to do it on your, try to start it on your own. So if we take a look here, what is my base? 2. So what is my parent function? Log base 2 of x. So I'm going to come here and say 2 to the power of f of x is equal to x. Again, are we plugging values in for x or y? Y, because we're plugging values for exponents. What are the 3 exponents that we are typically going to use?
0, 1, and
0, 1, and 2. Do you have to use those ones? No, but they're going to be the easiest ones for you to figure out. Because 1, you're not getting fractions. 2, they're low numbers, because you all should know your perfect squares, right? 2 to the power of 0 is? 1 to the power of, or 2 to the power of 1 is? And 2 squared is? 4. Go ahead and see if you can do this function here. Go ahead and see if you can graph this one. Figure out your transformations. How does it affect your table?
I think it's just everywhere.
What type of transformation do we have? Shift up 3, and what does that affect, your x's or your y's? Y's. Did we have any other transformations? No. So if you notice, all you're doing is adding 3 to your y values. So you should get 1, 3, 2, 4, and 4, 5. Yes?
Yes.
How do we do with that part? Good? All right, go ahead and see if you can fill in the rest of these characteristics real quick. Fill in the rest of your characteristics real quick. For the last video? Because did we shift left or right at all? No, so it's always going to be at x equals 0 if we don't shift left or right.
You can put any kind you want, as long as when we graph it, we have the same graphs.
Yeah, you can use any values you want. All up to you.
I'll talk about that.
I'll talk about that one.
Few things I want to talk about. Go ahead and check your answers up here for your domain, range, and behavior and asymptotic behavior. Before I get to the x-intercept, I want to talk about the asymptotic behavior. What side of the graph am I on, the positive or the negative? Positive. So I'm going to put what on the 0? Plus. Okay? For the x-intercept, this one is not a nice number, is it? No. So you could figure it out, yes. But what I would say for this one is just estimate. About roughly, where is it at? What 0? Half. So we can just come here and say 0.5, 0. For this one, let's just do that. I'm not going to make you try to figure it out with all the different things, okay? Questions? How do we do? Good? Are we getting better at graphing? Yes? All right, last page. Review. Why is this one review? It's exponential. So let me ask you this. What are my transformations here? Left 1, and what was it? Down 3. Okay. Do we need to figure out the parent function? No. How do we find points for this? Plug in numbers for x. So I'm going to come here and just make a quick xy table. Give me a number you would like to plug in for x. 0, okay. Let's go with 0. We have 0. If we plug in 0 here for x, we get 2. What's 0 plus 1? 1 minus 3. What is 2 to the first?
2,
Minus 3?
negative 1,
-1. So 0, -1. Give me another x value.
1,
1. I would get 2. What's 1 plus 1?
2,
4 minus 3 is?
1,
All right, give me one more. 2. What is 2 plus 1? 2 cubed is?
8,
Minus 3?
5,
5. Do we have to do any transformations on these points? No, because this is a table for this function. Okay, this table is for this function. We plugged in the values for x. So go ahead and plot those. 0, -1, 1, 1, and 2, 5. Before I connect these, what type of asymptote do I have? Is it horizontal, where it goes left to right, or is it vertical, where it goes up and down? Horizontal. Knowing that we went down 3 now, where is that horizontal asymptote at? -3. What is the equation of that, though? Y equals -3. Now that I have that drawn in, I'm going to come here and connect my points. Questions on graphing exponentials. It's been a while since we've done these, right? But we remember how? All right, let's fill in our domain and range. What is the domain of exponential functions? All real numbers, -infinity to infinity. What's the range of this exponential? -3 to infinity. Do we include -3? No. We do have an x-intercept, but this should say y-intercept. So change that x-intercept to a y-intercept. What is the y-intercept? 0, -1. Is x ever approaching an asymptote? Is x approaching an asymptote? Is x restricted? No. So do we have asymptotic behavior? No. Y is restricted. So the limit as x is approaching something, the limit as x is approaching something. If we go to the left, what is x approaching? -infinity. Which means the other one has to be infinity. All right, as we go to the left, what is our function doing? Where's our function going? Getting closer to what? -3.
Wait, that's what
I couldn't hear what you said.
Okay.
I heard you say the negative, that was it. Sorry. Bad hearing.
Hey, really wet.
All right, as x is getting bigger, going to positive infinity, where's our function going? Infinity. Again, what does our limit statements go along with? Domain and range. Our limit statements are always going to go along with our domain and range. So if you ever get stuck, go back to your domain and range. Okay? Questions? Katie.
Do you know about on the test what it'll be like? Like, is it going to be like the last quiz where it'll be on the calculator portion, or is it going to be on the
Non-calculator.
For exponentials?
Graphing is non-calculator. Completely. Other questions? No?